Okay, so as we talked about earlier, okay, we have mole equation stuff that we're going to work on today. I will remind you also that your reactions assignments are coming up due on the 11th. Okay, so make sure that you have those done. I've had a number of people come in to have me look them over, and okay, I'm still willing to do that if yours is done early. Okay, and you would like me to check it over, I will circle any of the ones that are not right. I won't tell you necessarily what's wrong about them, but I will tell you they're not right. You can go back and double check them, okay, as kind of the feedback for you on that. October. Okay, and reminder that I think today I will post the unit exam review. If I get around to it, it'll be today, if not, it'll be tomorrow. Okay, but that will be coming up on Google Classroom here later tomorrow. Okay, remember that it has two parts. Okay, that unit exam review will have some review activities, which you should do first, and then a practice test with a key. Okay, so do the practice test when you're closer to being done studying. Right, so that would be like closer to the 19th of October. I would say, maybe do it on the Monday, was that the 16th? Okay, something like that, do it then, and then you'll know what you still need to work on and what you need help with maybe. I would suggest doing it then. And guys, I will reiterate that that practice test is going to be just like your unit exam. Okay, like literally when you do the unit exam, you'll go, wow, this seems familiar. Okay, I only make small changes. I am trying to have you show me you can do the stuff that's important in this unit. Okay, so it is definitely worth your while to do those review activities. We have now covered everything in this unit. There's no more material for me to teach. There's time for us to master this, and that's it. That's what's left. All right? Okay. There's one of each type of mole equation question on the board right now. Okay? First two are like the ones on the quiz, so you'll get done those pretty quick. And the other two involve Avogadro's number. What are the only two things we ever do with Avogadro's number? Okay, when do I multiply by it? Nope. I actually never use it with big M. I use it with, I multiply by what part of the mole equation? The number of moles, n. Okay? If I'm trying to find the number of particles, is that a big number? How do you get big numbers? Multiplying or dividing? Multiplying, generally. I mean, you can get big numbers by dividing, but generally multiplying makes numbers bigger. Okay? And obviously I divide by it if I'm given the number of particles and I'm looking for a smaller number, like the number of moles. Okay? And I would divide by that. Right? Those are the only two things you're ever going to do. Okay, I will give you some time to get ahead of me, and then we'll walk through one at a time here, okay, over the next little bit. Yeah.
Would you ever have any spelling mistakes?
I don't think I have blue sleep, but I got some like online paper. Yeah. All right, so first type, okay, easiest type of mole equation question. How many moles of CaCO3? Did I make this one even easier? Because I didn't give it to you in words. I didn't give you the name. I gave you the actual formula, so there's no chance of misdoing, like not doing the drop and swap correctly or something like that. Okay? Incidentally, on your test, I give you the name, not the formula. Okay. So we've got CaCO3. We're looking for the number of moles, so we're looking for N. Okay, big M, CaCO3, okay, that's going to be 40.08, that's our single calcium, plus our single carbon, 12.01, plus 3 oxygens. 3 oxygens. Okay, when we calculate that, so 40.08 plus 12.01 plus 48. Okay, 100.09 grams per mole. All right, now we've got big M, and they also give us the mass, 125 grams. All right, so that would be a mark.
And we are looking for the number of moles, which does not require any manipulation of the formula, just to have the numbers plugged in. 125 divided by 100.09 should give me 1.25 moles, I would think. Yeah? Yeah. Or is it 1.24? Is it actually 1.24? It doesn't round up? 248, so it does round up. Moles. Okay. I could just punch it in the calculator if I'm being lazy. Okay. All right, questions on that one? Pretty straightforward. How many people have done the second one? Okay. Well, let's look at the second one while we're here. All right, what is the mass of 2.7 moles of lithium phosphide? So, what is the mass? We're looking for little m. Okay, 2.7 moles, that's N. And they tell us the material is lithium phosphide. So 6.94 is the atomic mass for lithium, and there are 3 of those. And we're going to add that to 1 phosphorus, so 30.97. Okay, so 51.79 grams per mole. Okay, so we have N, we have big M, and we're looking for little m. So that means we will have to manipulate so that we are isolating little m. That manipulation is to multiply both sides by big M so that we get that formula. And then we plug in our numbers, 2.7 moles times 51.79 grams per mole. Okay, and what we're really doing here is saying this is the mass of 1 mole and multiplying it by the number of moles we have. Okay, so times 2.7, 139.83 grams would be our mass, and that would be a 4-mark question most likely. Okay, mark for your algebra, mark for your math, mark for your answer. Okay, all right, give you a little bit more time on the Avogadro number ones. Okay, just so that you have it, Avogadro's number, okay, it is on the back of your periodic table at 6.02 times 10 to the 23. Yep. Okay. Anybody need help? All right, so on number 3, we're looking for how many molecules. As soon as I see the word molecules, I know I'm going to have to use Avogadro's number. Okay, so how many molecules? So we are looking for the number of molecules. Okay, of iron 3 oxide. Okay, so Fe2O3. Okay, so that's going to mean 55.85 times 2 plus 16 times 3. Okay, 159.7 grams per mole. Okay, for our molar mass, R in 230 grams. Okay, I have big M and little m. What can I calculate if I have those two things? And yeah, number of moles. Okay, that should be my next step then. So N is going to equal little m over big M, which is going to be 230 grams divided by 159.7 grams per mole. Okay, grams will cancel, I'll be left with moles. Okay, so we're looking at 1.44 moles. All right, so now I have the number of moles. What does Avogadro's number tell me?
Avogadro's number represents?
How many molecules are in like a mole?
Right, it represents how many particles are in a mole. Okay, so if that's the number for 1 mole, and I have 1.44 moles, what do I have to do with those two numbers? I have to multiply them, right? Okay, so the number of molecules equals number of moles times Av's number. Okay, so that's going to be 1.44 moles, okay, multiplied by 6.02 times 10 to the 23, and that's essentially molecules per mole. Okay, so the moles would cancel, I'd be left with molecules. All right, when I punch that into my calculator, I take all the decimals with me, and then I put Avogadro's number in brackets and multiply. All right, so I'm getting 8.67 times 10 to the 23 molecules. Okay, everybody all right with that? Okay, that would be a 4-mark question, right? You'd still get 1 for your givens. You'd get 1 for calculating the number of moles. Okay, you would get 1 for this calculation here, and 1 for your answer. Alex, question?
I thought you weren't supposed to round when you're like writing down the number of molecules.
No, when you are done, when your final answer, that one you round it.
Okay.
You can always round your final answer, just don't, nothing intermediate should be rounded. Okay, is it okay to go over number 4?
Yeah.
Yeah? Okay. All right, so number 4, they are telling me they want the mass, so that's little m, of a specified number of molecules. Okay, so the number of molecules is 5.42 times 10 to the 21. Is that more or less than a mole? A lot less. Okay? Like it's a factor of 10 to the 2 less than an actual mole. Okay, so is it okay if when I calculate the number of moles, I get a really small decimal? Yes, it is. That throws people sometimes, so that's why I bring it up. All right, so I've got the number of molecules, and I also have the material. It is nickel 2 nitrate. Okay, so when I'm calculating the molar mass, how many nickel do I have? 1. 59.63? 69. 58.69. 69. Okay, how many nitrogen do I have? 2. How many oxygen do I have? 6. Okay, on a question like this, what do you suppose people mess up? This. Okay, they'll mess up the molar mass. They'll do all the Avogadro stuff right, but they'll have the wrong molar mass at the end. Okay, so make sure that you're always being careful when you're calculating the molar mass. Okay, all right, so we have 58.69 plus 28.02, that's our 2 nitrogens, plus 16 times 6. 182.71 grams per mole. Okay, if I'm going to get little m, what do I need? I need the number of moles. I need n. Can I get n if I know how many molecules I have?
Yes.
Yes. All right, so I can get n if I take the number of molecules that I have and divide it by the number of molecules in 1 mole. Okay, that will leave me with number of moles, because this is molecules divided by molecules per mole. The molecules would cancel, and I'd be left with moles. Okay, so in brackets, 5.42 E21 divided by 6.02 E23. All right, 0.009 moles. Okay, and again, that's a number that, like, when people get it, it throws them, because oh, how could that be right? It's totally right. You have way less than a mole there. Doesn't mean you don't have a huge amount of molecules, you just have way less than a mole of them. Okay, all right, so now that I've got that 0.009 moles, now I have N and I have big M, so now I can go about finding the mass, little m. That's going to require our algebra. We're going to multiply both sides by big M, okay? And then we're actually going to plug in the math here, so that'll be 182.71 times 0.009, okay? Obviously with all the decimals that are in my calculator to get us our mass. All right, we have 1.64 grams of that stuff. Okay, are these pretty patterned?
Yep.
Yes. Right? So once you learn the pattern, just use the pattern. Okay, as long as you can identify which type of question it is, you have a pattern for each of them. Right? That's why we practice them. All right, I'll give you a 5-minute break, and then I'll put some other mole questions on the board here. Okay, so guys, just a quick reminder that in the classwork tab of Google Classroom, okay, the keys for all of the worksheets from this unit are present in there under chemistry worksheet keys, including all the mole equation worksheets. Okay, so if you're wanting to check answers as you work through those, okay, there's a key in there for that as well. Right, for right now, I would like you guys to be working on a couple of questions from the moly one. Okay, so guys, I would like you working on questions 2 through 7 for right now. Okay, some of them are fairly quick, like they're more of a recognition type of a question. Okay, and question number 2, you're looking for the number of moles, like you're looking for N, so it's not like there's a ton of work here. Okay, so I would like you guys to try 2 through 7, and then we'll kind of talk about those together, because there's probably going to be a couple in there that are going to seem odd, right? And they're important, so we'll talk about those odd ones here in a little bit. Okay, remember this is also in Google Classroom, so if you're having trouble reading it up here, okay, you can always pull it up on your phone and see it right in front of you. Okay, so the main question here that I want to address, okay, you guys shouldn't be packing up, there's still 5 minutes left in class, okay, would be question number 7, okay, which contains more atoms, a mole of oxygen gas or a mole of iron? Okay, the reason this gives people trouble is because they remember what I told them, which is a mole is always the same amount of particles no matter what you're dealing with. Except this question specifies the particles in question are atoms. So iron comes as single atoms when it is by itself. Oxygen is a special element, and oxygen gas is O2. So a mole of iron would have 6.02 times 10 to the 23 atoms of iron. But oxygen would have 6.02 times 10 to the 23 molecules of oxygen, each molecule containing 2 atoms. So it's double, exactly. 1 mole of oxygen gas would have twice as many atoms because oxygen gas, as its smallest particle, is a molecule, not a single atom. Does everyone follow the difference there? Oh, that question is not really asking you about the mole equation. It's asking you, do you know the difference between regular elements and special elements? Special elements come in pairs, quads, or octets. Okay? And so we have to just kind of understand how that part works. Does everyone follow on that one? Because it's kind of a tricky question, right? Like that could easily be a multiple choice question on a test, right? Which would contain more atoms, iron or oxygen. A, they have the same. B, iron. C, oxygen. D, impossible to know, okay? Or something like that, right? It would be an easy thing to put in as a multiple choice question because it tests your understanding of both moles a little bit, but mostly atomic structure, special elements versus non-special elements. Okay? Those are the kinds of things I do, right? Just so you're kind of, getting ready for it that way. Okay, I am composing an email right now to your parents, letting them know that today at 3:20, the review package will post in Google Classroom. That review package will include the things I've told you, the practice test and the review activities, and the keys for both, as well as a recording of last semester's unit exam review, which you guys will get next week. I'll do it in person next week, okay, but at least if you're, if you're not gonna be here or something like that, you can watch it ahead. I wouldn't watch it ahead of time, okay? But if you end up not being here the day I do it, you can watch that one, okay? And you'll have that as well, right? So I'm letting your parents know all of that, and I'm attaching all of those things to the email for them, so they are fully aware of what you've been given, okay, in order to prepare for your unit exam. I am not going to do that all semester long, just so you know, this is your first high school science exam, so I really, put it out there for you. Okay, but I'm gonna wean you off having quite so much as the semester goes along. Okay, this is gonna help you with that time management preparation, okay, stuff that goes on as you transition to high school. Okay? All right.